Hello, sorry I can't be here today. First things first, here is your 3.5 quick right. So if you guys go ahead and pause the video for everyone to answer this, since we have an entire week off for Thanksgiving next week, your quick right of the day is what are you most thankful for? Okay, welcome back. Unpause the video. Let's get started with 3.5 notes. So if at this point you guys haven't had note sheets passed out, make sure we get those. And here we go. So the first two lines here are the exact same definitions we have seen all unit. A system of equations is still a collection of two or more equations. And the solution to a system of equations is still the point that makes both of our equations true. Okay, whether you are in the room with me right now or watching this video, if you have your phone or a Chromebook out, put them away, please. All right, so what we are doing today is solving by substitution part 2. We did part 1 on Tuesday or Wednesday. The only difference between part 2 and part 1 is that we are going to be doing this first step today in part 2, which is that we are going to be responsible for solving out one of our equations for x or y. We learned how to solve equations for a certain variable back in section 1.8. So if you need to look back on how to solve for a variable, look back at 1.8. And then we've got a few examples that we're going to do here as well. Okay, so then steps 2 and 3, 4 and 5, 6 are the same as they were on Tuesday and Wednesday. We'll go over them once we get to them. So right here, we are going to start by practicing solving for x or y. So solving for a variable means we're getting it by itself. So we need to make our equation either be x equals or y equals. With these ones, we have to pick which ones it's going to be easiest to solve for. So right here, we've got x minus 2y equals 1. We need to pick which variable is already closest to being by itself. So what is closer to being by itself, x or y? X, because the x is there, the y has that -2 with it. So we in this one are going to solve for x. So I'm going to put a little note to myself so I know I am solving for x. So what that's going to look like to solve for x is I need to get rid of the -2y. How I get rid of the -2y is by adding 2y to both sides. So these two y's cancel, and I've got x equals 1 plus 2y. Okay. On this next one, what's closer to being by itself, x or y? Y. Because the x has a -3, the y doesn't have anything with it. So you're looking for the variable that's by itself already, and then we're going to get it by itself on that side of the equal sign. So we'll put a note to ourselves that says we're going to solve for y. And then how we solve for y, we got to get rid of that -3x. So we'll add 3x to both sides. So we have y equals, because these canceled, and then now I have 4 plus 3x. Okay. So those ones, x is very clearly more by itself than y, and then y is very clearly more by itself than x. This one down here we put on because it's a little bit tricky. We've got -x plus y. There are no numbers on the left side there. Which one of those is closer to being by itself, though?
X.
Okay, why are you saying y, Jace? Because there's not a negative. So we've got to remember that there's an imaginary -1 here. So even though we can't see it, there's an imaginary -1 there, and it's probably going to be easier to solve for y in this one. Because if I get rid of that y, I'll still have that -1 with it. So we are going to solve for y in this one as well. Solve for y. So we'll add 1x to both sides. And we'll get y equals -3 plus 1x. Hey, any questions about that one? Okay, we've got one more here. What's closest to being by itself in this one? X or y?
Y.
Okay, y doesn't have anything with it. Does x have anything with it? No. So these ones are equally close. So we're actually going to do this one both ways. You would only have to do it one way or the other. So you can choose if we wanted to solve for x or if we wanted to solve for y. So x plus y equals 17. To solve for x, I would get rid of the y. So I'm going to subtract the y, and I will get x equals 17 minus y. Top middle. Are you in JAG? Yeah, top middle. Okay. If we need to solve for y, x plus y equals 17. So that's our original equation. We would get rid of the x. So we could subtract x from both sides and get y equals 17 minus x. So we can do either one, and then that'll just depend whether we plug in for x or plug in for y. But those are both one step. We're never going to have to do more than one step to solve for x or y on these. And I did that on purpose. All right. Any questions about solving for x or y? Okay, so that is our new step 1. And we are going to add that in with how we have already been solving systems by substitution. So flip this over. Let's get started with these examples on the back. We just have 2 examples. These are both going to have real answers, one solution answers. I'm not going to do a no solution, infinite solution, but no solution and infinite solution happen the same way they happened in 3.4. So if your variables cancel out and it's false, it's no solution. If your variables cancel out and it's true, it's infinite solutions. Okay, so the first thing that we are going to do is we are going to look through our entire system. So I've got 4x plus y equals -3. And 2x plus 2y equals -12. And I want to pick the x or the y that is closest to being by itself. So what is closest to being by itself out of these 1, 2, 3, 4 options? The y in which equation? The y in the first equation. So I'm going to put a little arrow here and a little note to myself that says solve for this y. And then we can go ahead and do that. So I'm going to take that first equation. I'm going to rewrite it down here. 4x plus y equals -3. And I am going to solve for that y right there. So to solve for that y, I will get rid of the 4x by subtracting 4x. And I will end up with y equals -3 minus 4x. Okay, so now this equation is equivalent to our old first equation. We've just rearranged it. So we are ready for step 2 of solving our system, which is we are going to substitute that in to our other equation. So now that we know that y equals negative 3 minus 4x, we can plug that negative 3 minus 4x, or substitute it in for this y right here, because it is y equals. So we substitute in for things that are equal. So since it's y equals, we can put it in for y. Okay. So we've got 2x plus 2y equals negative 12. We will do 2x plus 2, and then we're plugging in negative 3 minus 4x for y. And that equals negative 12. Okay, from here, that was step 2, was to substitute it in. Step 3 is to solve for a variable. So we can now solve for x because we've got an x here and an x here. So eventually those will combine. So we're going to distribute right here. So this stays 2x. And then 2 times negative 3 is negative 6. 2 times negative 4x is negative 8x. And that equals negative 12. If at any point you guys get confused, pause me and let me know, or we can go back over the things we just did. Okay, so we distributed. Our next step would be to combine like terms. So we're going to combine together the 2x and the negative 8x. So 2x minus 8x is negative 6x minus 6 equals negative 12. And then from here, it's just a two-step equation. So we'll add 6 to both sides. We'll get negative 6x equals negative 12 plus 6 is negative 6. And then we divide both sides by negative 6. Get x equals 1. Okay. Any questions? What we just did was step 3 and solved for the first variable. Okay. So we are ready for steps 4 and 5 that go together. So step 4 is to plug in the answer we just found, x equals 1, back into our other equation. So we're going to plug it in here because this one's set up to tell us what y equals. We know that y equals negative 3 minus 4x. We now know that x equals 1, so we can put that 1 in here and figure out what y equals. So we're going to do that. Let me grab a color to show us what we're doing. We're taking this 1 and we're plugging it in here. So over here, I'm going to show my work for that. It's going to be y equals negative 3 minus 4x. We're plugging in 1, so it's going to be y equals negative 3 minus 4 times 1. Four times 1 is just 4, so this is y equals negative 3 minus 4. Negative 3 minus 4 is negative 7, so I get y equals negative 7. And then my last step, step 6, is to write my answer as an ordered pair. So if I write my answer as an ordered pair, x comes first. So this is 1, -7. That's my final answer. Okay. Is it a long process? Yes. There is no getting around that. Are you guys capable mathematicians that have been preparing up until now for this? Also, yes. Okay. I would like to recap the 6 steps. Step 1, we took the equation that y was the closest to solving for, and we solved for y. Step 2, we plugged that in up here for y, and then everything was in terms of x, and we solved for x. Then we took our x, plugged that in for x right there, and solved for y, because that's y equals. And then we wrote it as an ordered pair, x comma y. Okay, there is not space on here for me to show you how to check it, but I am going to show you in a calculator how you could check this if you wanted to. So grab a calculator, zoom out a little bit. So this is x and this is y. We would need to be able to plug in x and y into both of these. So what that would look like in a calculator is, put that on there, 4x, so that's going to be 4 times 1, plus, that's a 3, not a plus my y is -7, and that needs to equal -3, which it does. To check our other equation, we would also do 2x plus 2y, so it's going to be 2 times 1 plus 2 times -7, 2 times 1 plus 2 times -7, and we need to make sure that equals -12, which it does. So to check them, we plugged in x and y, x and y. So let me point to it with a smaller pin. This is x, that's a y, that's an x, that's a y, and we are plugging them in here for x and y, x and y. So if you ever wanted to check your solutions, that's how you could do that. Any questions right now? Okay, we're going to move on to our next one then. We've got one more. We solved for y in this one. I chose on purpose to give us an example where we're going to solve for x in this one, which I kind of just gave it away. I didn't tell you which x. Out of these 4 variables, 2x minus 3y, x, and 2y, which of those is closest to being by itself? The second x. So the x in the second equation. So we are going to solve for this x. Solve for this x. Okay, so I'm going to take that equation, pull it away, x plus 2y equals 15. And my goal is to get x by itself. So I have to get rid of that plus 2y. I have to subtract 2y from both sides. The opposite of plus 2y is minus 2y. I will get x equals 15 minus 2y. Okay, now that we know that x equals 15 minus 2y, we can plug that in for x in our other equation. So we have to plug it into the other equation. If we plug it into the same equation, we'll always get infinite solutions. So this 15 minus 2y is going to go in for the x in my first equation, since my second equation is the one I solved here. So I'll have 2x, but I'm plugging in 15 minus 2y. So it'll be 2 times 15 minus 2y. And then I've got minus 3y equals 2. No, because we replaced the x with the 15 minus 2y. So because we replaced the x with the 15 minus 2y, we do not need the x there anymore. Because when we substitute it in, just like if I were to get a substitute teacher, I don't show up. So since we substituted in something for the x, really good question, the x disappears. So we replaced it with something that is equal to it. Okay, so now I'm going to distribute, combine like terms, and solve. 2 times 15 is 30. 2 times negative 2y is negative 4y. And then I still have minus 3y equals 2. Okay, I've distributed. Any questions about distributing? Then we are going to combine like terms. So the negative 4y and the negative 3y, if I take $4 from you and then I take another $3 from you, I've taken $7 from you. So that is going to be negative 7y plus 30. I'm going to put it in that order because that's just the order we're used to more. We could also put 30 minus 7y, either way. Okay. And then I'll subtract 30 from both sides. We get negative 7y equals negative 28. It's 2 minus 30 is negative 28. And then we'll divide by negative 7. And we'll get y equals negative divided by negative is positive. 28 divided by 7 is 4. So I get y equals 4. Okay, now that I know that y equals 4, I can take that 4. We are ready for step 4 with our 4. We just did step 3. Now that I know that y equals 4, I take that 4 and I plug it in for this y here so that I can solve for x. So I will have x equals 15 minus 2y. So I'm using my x equals equation to solve for x. And I'm plugging in 4 for y. So that's going to be x equals 15 minus 2 times 4. Okay. 2 times 4 is 8. So now I have x equals 15 minus 8. And then 15 minus 8 is 7. So I get x equals 7. And then I can write my answer as an ordered pair. 7, 4, because x always goes first. So my ordered pair is going to be 7, 4. Okay, I showed you guys how to check on this one, or on the last one. For the sake of time, I'm not going to show you on this one. You would plug in both x and y for both x and y, and make sure that both of those equaled out, just like we did on our assignment on Monday of this current week. Okay, you guys can glue these notes in. Since I'm recording for first hour and third hour, since I won't be here tomorrow, I want to show them a couple things on the assignment, and I'm going to show you guys that too. So I'm going to show you guys a couple things on the assignment, and then I am going to get you guys, or give you the assignment so you can get started working on them. So the couple things I wanted to show you on the assignment, you have 6 problems. I said a couple things. I think there's only one thing. Directions, we need to show all work and write our answer as an ordered pair. On every problem, there's a letter. Once you get a problem done, you are going to take that letter, and then I put a little riddle on the back right here. Your goal is not to solve the riddle. The riddle is just a way for you to check yourself. And you know that if you didn't get one of these 6 answers, that you need to go back and find your mistake somewhere. So you are going to have one that's no solution. You are going to have one that's infinite solution. You still need to solve out all 6 problems all the way, because that's what we need to know how to do for our test. On the test, you won't have a riddle. Okay? Any questions right now? Okay, I'm going to go ahead and stop the video. If you are someone in my first or third hour who was absent watching this later and you have questions, email me and we'll get things figured out. Bye.